Something just changed inside the Sunday, not an explosion, not a flare, just silence. For a few brief minutes, solar instruments across 3 different missions detected a perfect gap, a missing note in the constant hum of radiation that fills our star. And when that hum returned, it came back shifted. A fraction of a millisecond small enough to vanish in the noise, yet identical to what happened the last time 3I Atlas moved through the inner system. It's as if the same visitor that once silenced Mars has found the sun's voice again. And this time, the entire solar system seems to be listening. Before we continue, take a moment to subscribe. Tell me where you're listening from, and the exact time right now, because from this point on, every update will matter. And what we're seeing tonight could redefine how the sun itself reacts to what drifts between the stars. It started with nothing. No burst, no warning flare, just a sudden stillness inside the data stream that watches the Sunday. For years, the background hum of solar radiation has been one of the most consistent signals humanity has ever recorded. The sun sings in every wavelength from radio to X-ray, a constant, living rhythm of plasma and magnetic fields twisting through fire. Yet on this morning, that rhythm faltered. The Parker Solar Probe, Solar Orbiter, and ground observatories across 3 continents all saw the same drop, a gap so narrow it should have been dismissed as noise. But it wasn't noise. The void was too precise, its edges were sharp, its frequency exact, and its timing matched something we've heard before, the same pattern recorded months earlier, when 3I Atlas brushed past Mars and left an unexplained silence in its wake. For 11 minutes, the sun fell quiet across one narrow band of the electromagnetic spectrum. Then, just as abruptly, the sound returned stronger, slightly phase-shifted, as if the entire solar output had been pulled a fraction out of tune. Engineers checked their equipment. Calibration routines showed nothing wrong. Parker's instruments were flawless. The silence was real, and it came from the sun itself. Astronomers call it an absorption anomaly. In simple terms, something interfered with the sun's radiation at a very specific wavelength, the same one used by the Deep Space Network to track interstellar objects. There was no flare to explain it, no plasma jet, no coronal mass ejection. The sun simply muted a single note of its own voice. That absence spread like a whisper through the community of heliophysicists. Data analysts compared timestamps. Every observatory recorded the event within seconds of each other. No signal delay, no parallax error. Whatever caused it was vast enough, or coordinated enough, to touch multiple points of space at once. The name on every internal report was the same: 3I Atlas. The third confirmed interstellar object ever observed a frozen body that had already shattered several rules of celestial mechanics. It had outgassed without measurable thrust. It had heated from within instead of from sunlight. And now, somehow, the frequencies surrounding it were being echoed by the Sunday. Some researchers framed it in purely physical terms. Perhaps the object carried a dense magnetic sheath, a halo of ionized dust, capable of resonating with solar plasma. If that sheath passed through the right region of the heliosphere, it might momentarily damp certain frequencies, the way a tuned cavity cancels sound in a speaker. Others were less convinced. The coherence was too perfect. Natural plasma noise loses structure within seconds. This signal held steady for minutes, and repeated with a rhythm tied to the object's rotation period. It behaved less like random interaction and more like synchronization, as if the sun and Atlas were briefly locked in dialogue. Whatever it was, the result could be measured. Solar wind density dropped by 4% across Parker's sensors. Local magnetic fields oscillated with a repeating phase. Even the flow of charged particles slowed, creating a faint ripple that propagated outward at hundreds of kilometers per second. A literal shockwave made of silence. No one announced it publicly. The event logs were archived, coded, and marked for correlation studies. Officially, it remains an unresolved transient, one of many small mysteries buried in the constant roar of solar data. But to those who were watching closely, it felt different. For the first time, the sun had not erupted outward in fury. It had drawn inward. It had paused. It had listened. And somewhere beyond the orbit of Venus, a small interstellar traveler continued its drift toward the inner system, quiet, cold, and somehow capable of making the brightest object in our sky hesitate. The universe has many ways to speak. Sometimes it does so by falling silent. The silence did not fade into nothing. It came back as a pulse. Hours after the solar gap closed, instruments began to record a new rhythm emerging from the background of the sun's radio noise. It was faint, at first, a tremor buried beneath the storm of ordinary plasma signals, but it repeated with a precision that no natural turbulence should ever maintain. Every 19 hours, the same narrow band brightened and dimmed like a metronome marking time in the vacuum. It was too clean to be static, too stable to be coincidence. At first, the data team suspected crosstalk between satellites. Parker Solar Probe, Solar Orbiter, and the Deep Space Network were all operating within similar frequencies. Maybe the sun's apparent heartbeat was simply interference leaking from our own transmissions. But when they cut the transmitters off, the pattern stayed. A signal without a source, a frequency that shouldn't exist. Across the next rotation cycle, the pulse sharpened. It held phase coherence over millions of kilometers, the same coherence once observed in the radio echoes, surrounding 3I Atlas as it passed Mars. When analysts overlaid both datasets, the alignment was almost perfect. The period matched the known spin of the object within a margin of seconds. That was when the whispers began. Could the signal be an echo? Heliophysicists proposed a cautious explanation. Perhaps the interstellar body carried a magnetized coma, dense enough to resonate with solar plasma. The sun emits countless harmonics waves that travel through charged gas like sound through air. If 3I Atlas crossed the right region, it might amplify one harmonic and reflect it back toward the star. The result would look like a pulse coming from within the sun itself, but the physics felt thin. Natural reflections scatter and decay. This pulse grew stronger with every repetition. By the third day, its amplitude had doubled. The Solar Dynamics Observatory registered corresponding flickers across the corona, localized brightness waves spreading outward from a fixed point on the solar surface. The timing lined up exactly with the radio bursts, light and magnetism moving as one. Engineers plotted the harmonic structure. It consisted of 3 narrow peaks, separated by precise integer multiples. A 3, 2, 1, pattern rarely seen outside human-made transmission systems. To some, that pattern meant mathematics. To others, it meant design. Still, caution ruled the conversation. The phrase artificial modulation never appeared in official memos. Instead, reports described non-thermal periodicities of unresolved origin. That's how science protects itself, by staying within the boundaries of proof. But off the record, several researchers admitted they had never seen a natural body behave like this. The question deepened when polarization data arrived. The European LOFAR array detected a 90-degree rotation in polarization every time the pulse peaked. That can happen only if the signal passes through a changing magnetic field, the same pattern you'd expect from a rotating emitter, or an aligned magnetic core. Could an interstellar comet possess a magnetic nucleus? The idea bordered on impossible. Ice and dust can carry charge but not sustained magnetism. To rotate the polarization so consistently would require a structured field, something solid, persistent, organized. The simplest explanation remained resonance, yet the symmetry defied that simplicity. Resonance drifts. This one corrected itself. When the Deep Space Network compared the solar pulse to the reflections they were still receiving from 3I Atlas, the frequencies were offset by only 0.004%. Small enough that a single shared oscillator could explain both. In other words, the sun and the object were pulsing together. Scientists tried to model it. Nothing worked. You can simulate plasma feedback, induced currents, wave coupling, but coherence over astronomical distance. That requires feedback. That implies a sender and a receiver. Somewhere between the star and the object, energy was being tuned, refined, and returned. By the end of the week, the pattern had stabilized into what engineers described as a phase-locked emission. It was no longer random interference. It was a dialogue, repeating across millions of kilometers of vacuum, steady enough to survive the chaos of the solar wind. And when the pulse reached its next harmonic peak, the sun flared not in light, but in magnetism. A global tremor in the heliosphere. Subtle, yet measurable. Whatever 3I Atlas had done, the sun had answered. And that answer arrived as the frequency that shouldn't exist. The first images looked ordinary, a smooth golden halo, the restless skin of our star. But when scientists overlaid consecutive frames from the Solar Dynamics Observatory, something strange appeared. A pulse of light sweeping across the corona, like a slow tide, brightening, fading, then returning again on schedule. The pattern did not match any known solar cycle. It wasn't a flare, nor a wave of heat from below. It was a mirrored echo, a shimmer that repeated at the exact interval of the 3I Atlas frequency detected days earlier. At first, analysts suspected an imaging error. Perhaps the detectors had saturated. Perhaps stray radiation from the spacecraft itself had bounced back into the camera. But when data from other observatories arrived, ESA's solar orbiter, Japan's Hinode, even amateur telescopes equipped with hydrogen alpha filters, the same ripple was there, moving across the solar limb with uncanny precision. The corona seemed to breathe in rhythm with an object, millions of kilometers away. To understand why that is unsettling, you have to remember how sunlight works. The sun's surface is chaotic, a boiling sea of magnetic plasma. Every flare, every coronal mass ejection, erupts from tangled magnetic lines snapping open and reconnecting. Nothing on that surface happens twice in the same way, yet these new pulses were ordered, symmetrical, almost engineered as if an invisible mirror were being held up to the star, bending its own light back upon itself. Spectroscopic readings deepened the mystery. The reflected wavelengths were slightly phase-shifted, meaning the light wasn't merely dimming or brightening, it was being redirected. Solar physicists called it coherent backscattering, a rare effect where waves interact with structured particles that resonate at matching frequencies. In laboratories, humans achieve it with carefully arranged mirrors and lasers, but there are no mirrors in space, not unless something builds them. The hypothesis grew quietly inside the data teams. If 3I Atlas was surrounded by a dense shell of charged dust, it might act like a moving lens, focusing and re-radiating sunlight back toward its source. Such a lens would have to be enormous, hundreds of kilometers across, yet its structure could remain invisible from Earth, seen only through the behavior of light itself. It would not reflect in the visual spectrum but in magnetism, shaping the flow of solar plasma the way a prism shapes a beam of light. When Parker's solar probe crossed the region where the ripple originated, its magnetometers registered a faint but repeating twist, magnetic fields rotating by fractions of a degree each time the corona brightened. That rotation matched the period of 3I Atlas's spin. Whatever was causing the reflection wasn't random scattering. It was synchronized motion. The discovery sparked an uncomfortable question. Was the sun being observed or manipulated? In scientific language, manipulation simply means influence energy exchanged, fields interacting. Yet the implication lingered. If the sun's outer atmosphere could respond to a distant body's magnetic rhythm, then the star's behavior wasn't entirely its own. The heliosphere itself had become part of the conversation. Subtle shifts soon appeared in the solar wind data. Ion densities fluctuated every 19 hours, the same interval as the brightness pulse. Even the direction of particle flow oscillated, as if invisible pressure waves were passing through space between the sun and the incoming object. To some it looked like feedback, a resonance loop between the largest furnace in the solar system and a traveller born between the stars. Publicly, the anomaly was described as a coronal reflection event, a tidy phrase that hides its scale. Behind closed doors, mission logs used a different term: mirror coupling, because the more scientists studied the pattern, the clearer it became that the sun was not just shining, it was responding. And as each pulse repeated, the mirrored glow grew stronger, spreading farther across the corona. The star that has never looked inward was, for the first time, reflecting on itself. For a comet, the night side should be a place of silence. When sunlight fades, the surface cools to near absolute zero, the vents freeze, and activity dies. But 3I Atlas refuses the ordinary script. Infrared telescopes across the world began noticing something impossible. Warmth radiating from the hemisphere turned permanently away from the Sunday. The first readings came from the James Webb Space Telescope, confirmed within hours by the Infrared Telescope Facility in Hawaii and the Gemini South Observatory in Chile. Every 6 hours, a cluster of hotspots flared to life, glowed briefly, then vanished back into darkness. They returned again 6 hours later, precisely 1/2 of the object's rotation period. It was too rhythmic to be coincidence, too organized to be chaos. Scientists called it localized thermal recurrence. To everyone else, it looked like the dark side of an interstellar object. Breathing. In ordinary physics, that cannot happen. A comet's heat must come from sunlight, and the energy it stores should dissipate as it turns away from the star. But Atlas was warming from within, releasing energy at regular intervals as if something below its crust were pulsing outward through cracks in the ice. Spectral analysis deepened the riddle. The emission lines around 10.6 microns indicated temperatures near 230 Kelvin, far higher than models predict for an object so far from direct solar radiation. No external process could account for it. There was no flare, no impact, no nearby plasma burst to trigger such heating. One explanation pointed to chemistry. Trapped volatiles reacting with embedded minerals, producing exothermic bursts as internal pressure rose and fell. If the nucleus contained layers of exotic ices, ammonia hydrates, carbon oxides, or complex organics, their phase transitions could generate brief waves of warmth, but that still wouldn't explain the timing. Natural reactions don't follow the precision of a clock. The other hypothesis was mechanical. A rotating core with fractures might flex under its own spin, converting torque into frictional heat. That mechanism exists inside moons like Enceladus or Europa, where tidal forces knead the ice. Yet 3I Atlas drifts alone in deep space, free of any gravitational partner. No tides, no stress, no reason for motion at all unless the motion is self-driven. When the European Space Agency cross-checked magnetometer data from Solar Orbiter, they found something subtle but persistent. Microcurrents surrounding the object, oscillating in step with the thermal peaks. That meant the heat was accompanied by magnetism, and magnetism means movement of charge. Something inside 3I Atlas was conducting electricity. The idea of an electrically active nucleus reshaped every conversation. If ionized gases were circulating through hidden channels, they could form loops of current that generate internal heat as resistance builds. Essentially, the object could be operating like a closed circuit, a cosmic induction coil warmed by its own electromagnetic field. In laboratory conditions, this would require design. In nature, it demands a material we've never encountered, a mixture of ice, metal, and carbon dense enough to sustain conduction without melting apart. If 3I Atlas truly carries that structure, it's a fossil from a system far older and colder than ours, a fragment forged under conditions no planet in our solar system ever experienced. But the story doesn't end with heat. Infrared light scattered outward from the hotspots in thin, coherent beams, not diffuse glows. They pointed roughly along magnetic lines traced by Parker Solar Probe, almost as though the energy release were guiding the plasma around it. Each beam pulsed softly before fading a flicker synchronized with the sun's own mirrored rhythm described in earlier data. By now, the pattern was undeniable. When the sun dimmed, Atlas flared. When Atlas cooled, the corona brightened. A silent exchange of energy looping across space, cause and effect blurred until neither could be named the source. In the cold mathematics of astrophysics, heat is just motion, but what we are seeing in 3I Atlas is coordination, a choreography between light and darkness, between a star and something that should have been no more than frozen rock. No one can yet say whether it is resonance, reaction, or something older than both. All we know is that the dark side of an interstellar object has begun to glow, and every time it does, the sun seems to listen. At first it seemed like background noise, tiny oscillations buried in the data streams flowing back from Parker Solar Probe. But when analysts synchronized the readings with those from Solar Orbiter, the pattern stepped into focus. Every 19 hours, the magnetic field around the sun flexed, expanding, contracting, then returning to balance. A cosmic inhale and exhale. Solar wind particles slowed during the contraction phase, then accelerated again as the field relaxed. Temperatures shifted by a few degrees, electron densities by a few percent, but always in perfect rhythm. The entire inner heliosphere appeared to be breathing. No one had ever recorded a magnetic pulse so global, so coordinated. The sun generates countless waves, Alfvén oscillations, standing modes, turbulence that dances through plasma like wind through grass, but none of them repeat this precisely. This was a heartbeat, not a storm, and as the timing models updated, the match became undeniable. The breathing aligned exactly with the rotational phase of 3I Atlas. Every time the object completed half a turn, the sun's magnetic field shivered. It was as if the interstellar visitor had found a frequency that resonated with the star itself. In physics, resonance is power. A small signal, applied at the right rhythm, can move mountains or stars. If 3I Atlas was emitting electromagnetic waves, even weak ones, and if those waves happen to align with the sun's natural modes, amplification could occur. Theoretically, a structure only kilometers wide could provoke measurable ripples across millions of kilometers of plasma. But to do that, the emitter would need knowledge of the medium's rhythm. It would have to listen first, and that's what unsettled the research teams most. The sense that the sun was no longer a passive participant, but part of a dialogue. Magnetometer traces showed phase coherence across space separated by astronomical units. From Parker's orbit near Venus to Solar Orbiter's path farther out, the same wavefront passed with identical timing. When plotted together, the graphs resembled lungs expanding in unison. The phrase magnetic breathing entered the mission logs quietly, first as shorthand, then as accepted terminology. It described the effect, but not its cause. Could the pulses be driven by solar rotation? No, rotation is slow and irregular. Could they stem from hidden sunspots? Sunspots don't coordinate hemispheres. Could they be echoes of the frequency detected earlier, the one that shouldn't exist? That explanation fit too neatly to dismiss. Further analysis revealed that the breathing wasn't uniform. It began strongest along the ecliptic, the same plane in which 3I Atlas travelled, and weakened toward the poles. That directional bias was the signature of an external driver. The sun was responding along a line. During one cycle, Parker's instruments caught a secondary pulse trailing the main wave by 9 minutes. The delay matched the travel time for charged particles moving from the region of space where the object was located. It was as though the sun inhaled, waited, and exhaled again through the corridor where 3I Atlas drifted. ESA analysts proposed a conservative model. Perhaps the object's magnetic tail was reconnecting with the solar field, creating oscillations much like a magnet brushing against another. But reconnection releases energy explosively, not rhythmically. These waves carried no violence, only precision. The consequences ripple beyond curiosity. If interstellar bodies can couple magnetically to a star, they can influence its wind, its radiation, even its stability. That means stars are not isolated. They are responsive, tuned instruments, capable of harmonizing with what passes near them. The implication is cosmic in scale. Every encounter between a star and an interstellar traveler might leave a signature, a faint rhythm written into stellar magnetism. For 3I Atlas, that rhythm now stretches across space, an invisible thread connecting the sun to something born between the stars. Each pulse is measurable, each breath predictable, and as the amplitude slowly rises, scientists face a question that no instrument can answer. Is the sun breathing on its own, or has something out there taught it how? When the sun breathes, it doesn't use air. Its lungs are fields of magnetism, and its heartbeat is heat. For days after the magnetic oscillations began, telescopes monitoring the corona, the sun's radiant outer skin recorded a strange glow that pulsed just beneath the surface. It wasn't a flare or a storm of plasma shooting into space. It was internal, a hidden wave of light moving from the base of the corona outward, spreading like ripples underwater. The phenomenon first appeared in ultraviolet data from NASA's Solar Dynamics Observatory. Every 19 hours, the emission lines of iron XIV brightened by a measurable percentage, then faded in perfect sequence. At first, the team assumed instrumental noise, but when Solar Orbiter and Hinode confirmed the same rhythm from different vantage points, the term pulse beneath the corona entered the mission logs. In the language of plasma physics, the corona is a delicate balance between confinement and escape. Its temperature sits near 1,000,000 degrees Kelvin, yet it hovers above a surface thousands of times cooler. For that to exist, magnetic loops must trap energy like invisible nets. But what happens when those nets begin to vibrate together, synchronized not by the sun's rotation, but by something external? As the data accumulated, patterns emerged. The brightness wave originated near solar longitude 247, precisely aligned with the vector toward 3I Atlas. Each pulse traveled through coronal loops at a velocity consistent with slow-mode magnetoacoustic waves, but their phase coherence extended across regions thousands of kilometers apart. Nothing that large should move in harmony unless driven by a single source. The amplitude of the pulses increased slightly with each solar cycle, hinting at feedback. When the object's magnetic field strengthened, the corona responded more violently, as though the sun's own heartbeat were echoing an external rhythm. Scientists tried to model it, resonance between two oscillating magnetic fields separated by millions of kilometers. The math worked, but only if both sides were actively adjusting, each compensating for the other's drift. That would mean the sun wasn't simply reacting, it was listening and replying. Spectroscopy offered another clue. During each bright phase, the coronal temperature rose by about 70 Kelvin, followed by a rapid cooling spike. Exactly 42 minutes later, the same interval seen in the low-frequency radio pulse that first exposed 3I Atlas's signature. It was a closed loop. The comet pulsed, the corona glowed, and the temperature waves returned like echoes in magnetic stone. Some researchers suggested that the pulses might be a byproduct of charged dust released by the object, now drifting through the heliosphere. When those grains interacted with solar radiation, they could modulate plasma density and trigger resonant waves, but that would require a cloud, spread across hundreds of millions of kilometers, dense enough to influence the sun's outer atmosphere, an implausible scenario by any natural standard. Others looked inward, proposing that the sun itself had entered a transient feedback state. Stars are nonlinear systems. Tiny external nudges can amplify into vast oscillations. Perhaps 3I Atlas had simply tapped a natural mode and awakened something dormant, a buried frequency that the sun hadn't expressed in recorded history. Whatever the cause, the effect was measurable. Solar wind velocity fluctuated by 3% in phase, with the ultraviolet pulses. Charged particles arriving at Earth's magnetosphere followed the same rhythm, producing faint auroral flickers every 19 hours over the poles. The entire heliosphere had begun to beat in sync. For the first time, the team stopped calling it a coincidence. The sun was pulsing, and the pulse was not random, it was timed. When the next cycle began, the corona brightened earlier than predicted, as if anticipating the signal rather than waiting for it. Feedback had become foresight. A star, it seemed, had learned the rhythm of a visitor from another world, and now kept time with it. In laboratories on Earth, that kind of synchronization requires design, intention, and control. In space, it requires something we still don't understand. The pulse beneath the corona continues steady, patient, impossible. It may fade with distance, or it may strengthen as 3I Atlas moves closer. But one truth has already emerged from the data. The sun is no longer alone in its own rhythm. The first sign that something larger was happening came from the edge of the solar system. Beyond the orbit of Neptune, the Voyager probes continued to send home their faint, fragile signals, whispers carried across the void. For decades, those signals had remained steady, the hum of interstellar plasma brushing against the boundary of the heliosphere like a slow tide. Then, without warning, the tide moved. Both Voyager 1 and Voyager 2 detected an unexpected fluctuation in the surrounding plasma density, a soft surge that arrived at precisely the same moment the sun's coronal pulse peaked. The two spacecraft are separated by more than 130 astronomical units, yet they recorded the same compression wave within hours of each other. That timing should have been impossible. Even at the speed of the solar wind, it would take weeks for a signal to propagate that far. Whatever passed through them was not carried by matter, it was carried by field. Scientists called it a global heliospheric ripple, a coordinated shift in the boundary that separates the sun's influence from interstellar space. It was as though the magnetic bubble around our solar system had flexed, tightening for a moment, then relaxing again like the surface of a breathing lung. At first, the explanation was simple. A solar wind pressure front. The sun often releases pulses of charged particles that push the heliosphere outward, but these waves move irregularly, their timing chaotic. This one was orderly, predictable, and its period matched the 19-hour pulse that had been echoing through every layer of solar observation since 3I Atlas drew near. The heliosphere, the sun's invisible shield, had joined the rhythm. Models run at the Goddard Space Flight Center showed that the ripple propagated through the entire structure as a standing wave, a vibration resonating along magnetic field lines that stretch billions of kilometers. To sustain such a wave, the energy input would have to be vast. Yet there was no flare, no coronal mass ejection, no burst of radiation to power it. The energy source was invisible, as if the sun had been struck by something that left no trace but motion. The Interstellar Boundary Explorer, IBEX, spacecraft provided another clue. It recorded a shift in the flow of energetic neutral atoms, particles that map the shape of the heliosphere itself. The map distorted slightly, bending inward along the direction of 3I Atlas's approach. The distortion wasn't random. It pulsed, flickering in near-perfect rhythm with the magnetic breathing closer to the Sunday. That alignment forced a disturbing realization. The heliosphere was no longer a passive boundary. It was reacting. The entire solar system, from the corona to the outermost edge of its protective bubble, was vibrating as one structure. Theorists debated the possibilities. Could 3I Atlas have ejected a stream of charged particles powerful enough to interact with the sun's magnetic field from afar? Could its tail be carrying magnetized dust that modulated the interplanetary current sheet, the vast electrical plane that connects every planet to the sun? Or was this something subtler, a resonance between two magnetic domains, the field of a star and the field of an interstellar traveler momentarily locked together like tuning forks separated by light years? The ripple revealed more than motion. It exposed vulnerability. For the first time, humanity had witnessed the solar system respond to an external rhythm, not from a nearby planet or a passing storm, but from beyond. The physics held, but the implications did not. If one object could synchronize with the sun's field, what could happen when dozens or hundreds of such travelers passed through the galactic neighborhood? Would each leave a fingerprint, a small modulation written into the heliosphere's memory? Would our star hum differently after every encounter, slightly altered by each interstellar breath? When the ripple faded, Voyager's instruments returned to normal, but the plasma around both probes stayed subtly denser, as though the boundary had been permanently nudged inward by a fraction of a percent. Even a small change at that distance translates to millions of kilometers. To the public, it was just another anomaly buried in telemetry. To those who study the sun, it was something else entirely, proof that whatever 3I Atlas had triggered near the corona had now reached the very edge of the sun's dominion. The heliosphere, the great magnetic cocoon that shields every planet, every orbit, every signal we send, had rippled once. And once is all it takes to know it can happen again. It began with brightness, but not with noise. The sensors caught the rise before the eye could. A shallow swell in the sun's light curve, smooth as breath, absent of every feature that defines a flare. No eruption, no X-ray surge, no violent halo expanding across the corona. Just a steady bloom of energy that seemed to appear, hold, and vanish without consequence. And yet, every instrument felt it. Parker Solar Probe's magnetometers fluttered. SOHO's detectors registered a brief, perfect symmetry in the solar wind. Across the globe, ground-based observatories logged the same event. A flare that released light without heat, motion without shock, power without sound. At first, scientists dismissed it as a calibration error. Perhaps two instruments overlapped signals, producing the illusion of brightness. But when the timestamps aligned within seconds across 3 independent spacecraft, the explanation collapsed. The data were clean. The flare had happened. Only there was no explosion to make it happen. Solar flares are driven by magnetic reconnection. Fields twist, snap, and hurl plasma outward at millions of kilometers per hour. The process is violent, and the radiation it produces is deafening in every wavelength. This event broke every rule. The magnetogram beneath the flare zone showed no collapse, no disconnection. Instead, magnetic lines there rotated. They turned inward on themselves as though folding around an invisible axis, then realigned, stronger than before. The rotation frequency matched the now familiar rhythm 19 hours. Each cycle, the corona flinched in the same place. A silent flicker on the sun's surface that repeated with clockwork precision. It was as if something were pressing gently on the star's skin, testing its response. Spectral analysis deepened the puzzle. The wavelength profile of the flare carried a narrow absorption notch exactly at 8.4 GHz, the same band that vanished during the first solar silence when 3I Atlas passed Mars. That coincidence drew a straight line between events months apart, linking the flare to the interstellar object now drifting toward the inner system. Researchers at the Goddard Space Flight Center modeled the phenomenon as magnetic inversion. If an external magnetic field couples to the sun's surface, it can momentarily trap energy instead of releasing it. A negative flare, an implosion of light. Energy doesn't explode outward. It collapses inward, releasing radiation with no accompanying heat. It's a theoretical state that has never been observed until now. When the flare reached its midpoint, Parker's instruments recorded a brief dip in the solar wind, a vacuum pocket moving outward like the wake of something invisible. Then the field stabilized. No ejection, no shock, just silence. The effect propagated far beyond the Sunday. Earth's magnetosphere shifted by a fraction of a degree, Satellites experienced micro-fluctuations in current, and auroral cameras captured a faint symmetric ring over the poles, a circle of light with no storm to explain it. Astronomers began to call it the silent flare, a term that spread through research papers and headlines alike. Some described it as resonance, others as interference. But one phrase returned in private correspondence between heliophysicists: energy compression event. It meant that the sun, for a few minutes, had behaved like a resonant cavity, a place where waves reflect perfectly and cancel their own noise. If that description is correct, it implies control. To cancel a flare, you must know the exact frequency of the chaos you're suppressing. You must act in perfect opposition. Either 3i Atlas carries that precision, or it has found a way to learn it. As the brightness faded back into equilibrium, one last anomaly appeared. A faint secondary pulse, delayed by 42 minutes, mirrored the flare's curve in reverse. A reflection coming not from the sun, but from the direction of the approaching object. Light left the star, echoed through space, and returned, slightly altered, as though it had been acknowledged. When the data ended, silence filled the spectrum again. The sun turned quiet, waiting, and somewhere beyond Venus, the traveller that had caused no explosion, no sound, no heat, continued on its path, leaving behind only a flare that never made a sound. For centuries, gravity has been the one constant no star or planet could defy. It is silent, absolute, and unforgiving. It bends light, anchors orbits, and dictates the shape of everything we see. But during the days following the silent flare, the numbers no longer held steady. Deep space tracking stations began to notice a drift, tiny, almost imperceptible changes in the trajectories of inner planets, fractions of a millimeter per second, recorded by the most precise radar systems ever built. At first, they blamed calibration, thermal expansion in antennas, software errors, subtle biases in the orbit models. But as the corrections piled up, the anomaly refused to vanish. Earth, Mars, and even the solar probes seemed to weigh slightly less. Not much, just enough that the sun's gravitational pull appeared to weaken by 1 part in a billion. And then, 42 hours later, it returned to normal. The event repeated twice more in perfect rhythm with the magnetic breathing cycle. Each time, the same pattern unfolded. The sun's grip loosened, stabilized, and tightened again. It was as though the star itself were inhaling, exhaling, and in those brief pauses between breaths, the force that binds the solar system flickered. Theorists at Caltech and ESA ran the numbers again. A gravitational fluctuation on this scale would require a redistribution of solar mass. Billions of tons moving in and out of equilibrium without a corresponding flare, quake, or shockwave. No known mechanism could achieve it, and yet, every orbit-tracking beacon confirmed the same pulse. Some compared it to a phenomenon known as mass quadrupole resonance, a tiny oscillation in a body's gravitational field caused by periodic internal motion. In stars, it's usually microscopic, but here, it was measurable across planetary distances. Something was modulating the sun's internal mass distribution from the outside. Attention turned back to 3i Atlas. The object was still millions of kilometers away, yet every fluctuation in gravity aligned perfectly with its approach vector. If it were emitting electromagnetic waves in the right range, they could, in theory, induce density waves inside the sun, compressing and expanding layers of plasma, momentarily altering the distribution of gravitational potential. Essentially, a resonance between matter and magnetism, but the precision was too high to dismiss as chance. The phase delay between each fluctuation and each flare was identical. The same signature kept repeating, the 19-hour rhythm that now seemed to define the entire system's heartbeat. Then came a deeper shift. During one pulse, Parker Solar Probe's onboard gravimeter recorded a drop in local acceleration, as if the very space around it had relaxed. Not a reduction in mass, but in curvature, the invisible geometry of gravity flattening for a fraction of a second before snapping back into place. It was small enough to miss in raw data, but too consistent to ignore. One researcher described it simply: the sun blinked. If space itself can blink, it means that gravity isn't entirely immune to influence. It can resonate, respond, maybe even harmonize. Every major observatory was now watching the same rhythm ripple outward. Light, magnetism, plasma, and now gravity, all moving in sync with an interstellar traveler smaller than a city. Was it coincidence? Or had 3i Atlas tapped into something fundamental, a hidden feedback between motion and mass, between geometry and sound? Could a comet-sized body really tug on the sun's structure without touching it? If so, we are witnessing a physics experiment written by the universe itself. When the last pulse faded, the solar system fell silent again. The planets resumed their paths, gravitational models rebalanced, but in the heart of every dataset remained a gap, a moment when gravity hesitated, as though the oldest law in creation had paused to listen. And somewhere beyond Mercury's orbit, the source of that hesitation continued forward, dragging a trail of invisible waves behind it. The solar wind has always been considered a one-way current, a river of charged particles flowing endlessly outward from the sun, carrying heat, magnetism, and fragments of solar breath to the edge of the system. Nothing returns against it. Nothing reflects. At least, that was the rule. Then, the probe started hearing echoes. In early telemetry from Parker Solar Probe and Solar Orbiter, tiny reversals appeared in the particle velocity data. Streams of protons travelling back toward the Sunday. They were faint, scattered, but synchronized with the 19-hour cycle that had now infected everything from the corona to the heliosphere. The direction of motion, the timing, even the density curves all aligned with the trajectory of 3i Atlas. At first, it seemed impossible. Solar wind reflections can occur when high-speed plasma collides with slower material ahead of it, but those fronts form at random, chaotic intervals not like this. This was organized, repeating, and spatially coherent across millions of kilometers. Analysts isolated the signal and found something stranger still. Each reflection carried a slight frequency shift in its magnetic field, a modulation resembling a mirrored waveform of the sun's own emission. The shape wasn't identical, but inverted, as if the solar wind were bouncing off an unseen surface that translated light into magnetism and sent it back. One scientist compared it to sonar, a ping and an echo, except here, the ocean was space, and the sound was sunlight transformed into charged motion. Where could such reflection occur? There are no mirrors in the solar wind, no boundaries dense enough to reverse the flow. Even planetary magnetospheres merely deflect, not reflect. But 3i Atlas was moving through a region of plasma dense with dust, a sheath of ionized material surrounding it, like a translucent cocoon. If that cocoon carried structured charge layers, it might act as a dynamic reflector, a field that could receive solar plasma, realign it, and send it home. The calculations were disturbing. To invert the flow that way would require controlled magnetic alignment, adjusting in real time as the solar wind shifted. Nature rarely builds systems that self-correct with such precision, yet every new reading showed the same feedback. As Parker approached the next predicted phase, it detected a reversal wave, travelling at exactly 400 kilometers per second, the same speed as the outward flow, two opposing currents colliding silently in the void, cancelling momentum and leaving behind a thin region of stillness. That stillness, a pocket where the sun's breath and its reflection met, produced measurable interference in electromagnetic readings. Frequencies dropped, temperature gradients flattened, and for a brief moment, the space between the probe and the sun went quiet. Even radio static faded. It was a silence inside the wind. When the analysis reached Earth, researchers at NASA's Goddard Space Flight Center plotted the vectors and realized the symmetry lined up perfectly along the Atlas-Sun axis. The reflections weren't random at all. They formed a corridor, a narrow, invisible channel linking the interstellar object to the star it was influencing. If correct, that meant the solar wind was no longer a simple outflow. It had become a feedback system, a loop connecting emitter and receiver, as if the sun were sending data and 3i Atlas were responding. Some theorists suggested that this feedback could explain the gravitational hesitation recorded earlier. When plasma flow reverses, the dynamic pressure in the heliosphere changes, momentarily altering the effective mass distribution around the Sunday. Gravity doesn't weaken, it resonates. The entire solar system moves slightly in response. Others weren't convinced. To them, the reflections looked intentional. Too clean, too rhythmic, too persistent. If it were coincidence, it was the most coordinated coincidence in recorded astrophysics. The public will likely never know the term the internal reports used, but among the scientists who worked the data, the phrase spread quietly, reflective coupling, because for the first time, sunlight, the purest form of outward energy, had been answered. Particles sent into the void were coming home, carrying information they should never have gained, encoded in the rhythm of an object that was never supposed to exist. And in that feedback loop, that delicate reflection, some believe the sun may have found not just resistance, but recognition. When the reflections first appeared, scientists assumed the particles would fade back into randomness once the wavefronts collided. Instead, they began to organize. For days, instruments on Parker Solar Probe, Solar Orbiter, and Stereo A recorded a slow migration of charged dust and plasma filaments bending away from their expected paths. The solar wind no longer streamed evenly from the sun. It curved subtly, deliberately toward the line that connected the star to 3I Atlas. Each particle's trajectory seemed nudged by an unseen hand, forming long, translucent arcs that traced invisible geometry through space. To the naked eye, there was nothing to see, but when magnetohydrodynamic data were rendered in false color, the pattern emerged like veins of light inside a living body. Protons, electrons, and micrometer grains of silicate dust were drifting sideways, not outward, gathering into faint corridors that pulsed with current. It was motion without propulsion, organization without command, yet every curve pointed toward the same origin. Physicists called the effect vector bias. The sun's field lines had bent, creating paths of least resistance that guided particles into alignment. Ordinarily, such behavior requires large-scale magnetic storms or planetary magnetospheres. Here, there was neither. Something smaller and far more exact was shaping the current. The drift extended far beyond what any natural bow shock could sustain. At one point, Solar Orbiter detected coherent motion across 4 million kilometers of space. All of it followed a repeating cadence of 19 hours, the same rhythm that now defined everything touched by 3I Atlas. Wherever the object passed, space itself seemed to fall into time with it. Theoretical models suggested that if the body possessed a rotating magnetic field, even a weak one, it could create standing Alfvén waves in the solar wind. Those waves would push and pull on charged particles, herding them into parallel streams. But the magnitude of the effect defied expectation. The drift wasn't local. It was system-wide. Particles near Mercury showed the same directional bias as those near Mars. The heliosphere had become a single, slow vortex, its outer layers gently turning toward the interstellar visitor. For engineers who monitor spacecraft, the consequences were immediate. Solar panels reported brief surges in current. Static buildup on antennas fluctuated with the same period as the drift. Some deep space probes experienced minute course deviations, as if sailing through invisible eddies. No alarms were triggered. The forces were too small to endanger hardware, but the precision unsettled those who understood the math. Energy this subtle shouldn't persist across such distance. Researchers at CERN and NASA Goddard proposed a provocative idea. The drift might not be purely magnetic. If 3I Atlas's emissions included charged dust with high reflectivity, each grain could carry an electrostatic potential, turning the solar wind into a coupled plasma dust medium. In that state, particles communicate through fields rather than collisions. Information moves faster than matter. The drift could therefore represent a kind of distributed signal, a pattern etched into the plasma itself. The evidence grew stranger. Spectrographs aboard Parker detected microbursts of radio emission embedded within the drift, each one lasting less than a second. Their frequencies followed the same three. 2. 1. Harmonic pattern first seen in the earlier magnetic breathing. When the bursts were translated into audio for analysis, they produced a tone low, steady, hauntingly human in its rhythm. It wasn't sound, but structure, a resonance that hinted at intention. For the first time, some scientists allowed themselves to say it aloud. It's communicating through motion. Whether that motion was deliberate or emergent didn't matter. The physics remained extraordinary. Particles that should scatter randomly were now tracing coordinated paths through billions of kilometers of solar space, as if the wind itself had learned to follow instructions written in magnetism and time. When the drift finally subsided, the plasma returned to chaos. But a residue lingered, fine dust spiraling along field lines, forming a thin filament that glowed faintly in the ultraviolet. From Earth's orbit, it resembled a thread connecting the sun and the distant traveler, a line of charged light slowly twisting through vacuum. And though the motion faded from sensors, some instruments still register a faint periodic whisper, every 19 hours, a reminder that once, the solar wind reflected something greater than itself, and for a brief moment, the particles of the sun obeyed another rhythm. At first, the structure existed only in data, a thin alignment of field lines running like a thread between the sun and the incoming body, visible only through the behavior of charged particles. But as the drift intensified, that thread thickened. What began as coincidence solidified into architecture. Analysts at NASA Goddard and ESA's Solar Orbiter team traced the pattern through magnetogram reconstructions. They found a continuous flux tube, millions of kilometers long, connecting the inner corona to the region where 3I Atlas was traveling. Inside it, the magnetic field was smooth, coherent, and unusually stable. No turbulence, no random shear, a corridor. In ordinary solar wind, magnetic lines twist and snap like tangled ropes. They tangle around planets, fold into current sheets, and shred themselves in reconnection events. Stability on this scale should be impossible, yet the corridor held its shape for days, anchored at both ends by forces no model could describe. Parker's solar probe crossed its edge on what should have been a routine orbit. For exactly 11 minutes, every instrument aboard recorded the same anomaly: a sudden drop in particle temperature, a doubling of magnetic coherence, and the near disappearance of background noise. Space, usually loud with static, became eerily calm. Within that silence, faint oscillations rippled at intervals of 19 hours and 42 minutes. The same pulse, the same rhythm. Mission Control replayed the data again and again. It wasn't a field fluctuation. It was guidance. The corridor behaved like a transmission line channeling energy, not dispersing it. Each wave that entered from the sun's side emerged hours later along the vector of 3I Atlas, attenuated but intact, as if information were flowing through a magnetic wire stretched across space. Some called it a flux bridge, others a magnetospheric tether. Whatever its name, it rewrote assumptions about how magnetic fields interact across astronomical distance. Fields should diffuse. This one communicated. The implications were staggering. If an object could shape a stable corridor between itself and a star, it could in theory exchange energy directly, siphoning charged particles, feeding current, or simply sampling plasma density in real time. It was a link, a conduit between two realms of gravity and light. Engineers compared the readings to induction coils used in wireless power systems. The analogy fit too well. When the sun pulsed, the corridor vibrated. When 3I Atlas responded, a faint back pulse returned. Each side tuned to the other's frequency, maintaining equilibrium. It was electromagnetic symbiosis. The visual evidence arrived next. Coronagraph images from SOHO revealed a faint filament arcing outward from the sun's equator. A luminous ribbon twisting through the dark, faintly green in polarized light. It was barely visible, but its orientation matched the magnetic maps exactly. Observers nicknamed it the thread. Within hours, sensors across multiple spacecraft detected enhanced radio transparency along the same path. Signals transmitted through the corridor arrived cleaner, as if the turbulence of space itself had been filtered out. Communication across millions of kilometers suddenly improved by measurable degrees. The corridor wasn't just stable, it was organized. Somewhere inside it, chaos had been cancelled. When Parker exited the structure, the noise returned. Plasma buffeting, magnetic jitter, the ordinary static of space. The calm was gone. Whatever maintained the corridor existed only while both ends remained aligned. As 3I Atlas drifted onward, the flux tube bent, thinned, and slowly dissolved. Yet the instruments had seen it. A magnetic connection, bridging a star and an interstellar object, two bodies sharing current, information, and silence. For the scientists who study fields, it was more than anomaly. It was revelation. Magnetism, they realized, could act as dialogue. The universe had found a way to speak without sound, and in that corridor of invisible light, the sun and a wanderer from another world had held their first conversation. The corridor dissolved, but the light did not. When Parker left the magnetic bridge behind, a faint afterglow lingered in the sun's corona, a soft, symmetrical brightness that refused to fade. It was not a flare, not scattering from dust, and not an instrument echo. It was stillness made visible, illumination that stood in place as if waiting for something to return. The first analysts to study it assumed a simple explanation: residual heat trapped in the plasma loops. But the brightness behaved differently. Instead of cooling, it held steady for 19 hours, dimmed for 42 minutes, then reignited to the exact same intensity, every cycle repeated with millisecond precision. No known solar process is that disciplined. Spectroscopy added another layer of strangeness. The emission lines were sharper than normal, suggesting that the glowing plasma was unusually uniform. Its temperature hovered around 1 million Kelvin, slightly lower than the surrounding corona, yet its luminosity was higher. In physics, that combination should not exist. Colder gas should shine less, but here, cold was bright. ESA's solar orbiter confirmed the phenomenon from another angle. From its vantage point above the ecliptic, the patch of light appeared perfectly circular, a luminous disk centered on the coordinates once occupied by the root of the magnetic corridor. It did not rotate with the Sunday, it remained locked in place, tethered to a fixed longitude that corresponded to the current position of 3I Atlas along its trajectory. The conclusion was uncomfortable. The Sun was projecting light toward a point in space, as if illuminating the path of its distant counterpart. Some researchers described it as a magnetic lensing event. The field lines distorted so precisely that plasma density increased in a confined zone, focusing radiation like a cosmic spotlight. But when they modeled the geometry, the numbers suggested the focal point lay not at random. It aligned exactly with the approaching object. The brightness was aimed. Observers on Earth began to notice subtle consequences. Solar irradiance fluctuated by fractions of a percent, enough to shift satellite sensors and climate models. Ground-based coronagraphs detected faint waves of polarization sweeping through the corona, ripples of light curling outward from the bright patch like concentric rings on water. Each wave reached the same amplitude, then dissipated into nothing. Energy was being released, paused, and released again, a heartbeat of illumination. When the timing was plotted against all prior anomalies, the magnetic breathing, the silent flare, the heliospheric ripple, the same interval emerged. 19 hours, 42 minutes. A pattern so consistent that even skeptics began calling it the Atlas clock. Inside data centers, teams watched the cycle unfold in silence. There was no explosion, no violence, only patience. It felt like waiting, a communication without words, where the message was persistence itself. Some proposed that the glow marked the point where the Sun's energy funneled into the remaining corridor, a standing wave frozen between resonance and decay. Others wondered if it was the Sun's own attempt to maintain connection, a lighthouse signal sent into the dark, sustained by memory of what had passed through. Then, during one observation window, the brightness dimmed unexpectedly. For the first time, the light failed to return at the scheduled moment. In its absence, background radiation from the corona dropped by a measurable amount, as though the region had absorbed rather than emitted energy. Minutes later, a faint spike appeared in instruments facing the opposite side of the Sun, a mirror pulse, weaker but identical in spectrum, emerging along the direction of 3I Atlas. The light had moved. It was not extinguished. It had travelled. Energy that once stood motionless had crossed the void, bridging the distance through a mechanism no one could yet describe. And so the scientists named it the brightness that waited, because for hours it had stood still, watching, until at last it decided where to go. Mercury was never meant to be part of the story. It's a silent world, airless and scorched, orbiting so close to the Sun that its daylight side glows with reflected fire and its night side freezes to stone. No atmosphere, no magnetosphere worth naming, nothing capable of carrying echoes. And yet, somehow, it did. When the brightness left the corona and vanished into space, most assumed the cycle had ended. But within a single rotation of Mercury, the Bepi-Colombo spacecraft recorded a wave that no one expected. A faint surge in magnetic pressure rolled across its instruments, a pulse too regular to be random, too narrow to be a solar gust. It arrived precisely 19 hours after the last flare of brightness faded. At first, it seemed like interference from the Sunday, but when Parker Solar Probe and Solar Orbiter compared readings, the timing triangulated. The pulse had not come from the Sun at all. It had come from beyond Mercury's orbit, from the same direction as 3I Atlas. The phenomenon was subtle, a whisper of plasma moving against the solar wind, drifting sunward rather than away, as though a returning signal had touched Mercury's magnetotail and left an afterimage of current. The field twisted, shimmered, and then stilled. The surface instruments detected no impact, no heat, only resonance. An echo. For hours, the planet's night side reflected a glow, invisible to the eye, but captured by ultraviolet spectrometers. A thin ring of ionized sodium atoms vibrating in harmony with the incoming wave. Each oscillation matched the frequency of the Atlas clock. It was the same 19-hour rhythm written now in the atoms of a planet's exosphere. Scientists struggled to name it. Some called it plasma rebound, others magnetic feedback reflection. Neither fit. Rebounds decay, this one repeated. Feedback requires an emitter and a receiver, and Mercury has neither. Unless, of course, the entire solar system has become the receiver. Data from Bepi Colombo's magnetometer showed another anomaly. During each pulse, the local field momentarily realigned north-south instead of east-west, as if a larger field, invisible but dominant, had passed straight through the planet. The signal was coherent enough to suggest structure. A carrier wave imprinted with faint modulation. When transformed into audio for analysis, it produced a single, low tone. Steady, haunting, impossibly human in tempo. If this were terrestrial physics, it would resemble induction. A moving magnetic corridor brushing against a conductive body can create secondary currents, echoes of motion encoded as electricity. Mercury, dense and metallic, was the perfect conductor. It had become a bell struck by a wave that should not have existed. The tone faded after 6 cycles, leaving behind a residual enhancement in Mercury's tail plasma. But before it vanished completely, Parker's sensors caught something extraordinary. A small reversal of flow particles moving sunward along the same vector as the echo. Energy had been sent back. The system had answered. In mission control, no one spoke for several minutes. Charts and graphs scrolled by in silence. Every signature, the 19-hour pulse, the harmonic ratios, the polarization shifts matched the patterns traced all the way from the corona to the heliosphere. It was as if the conversation between the Sun and Three-Eye Atlas had found a new voice, using Mercury as the intermediary. The world closest to the Sun, long ignored except as a relic of formation, had joined the rhythm. Its metallic heart had caught the song of an interstellar traveler and sung it back across the void. No explosion, no flare, no dust, just an echo, quiet and exact, ringing over a planet that was never meant to speak. And somewhere beyond the orbit of Venus, that echo continues its journey, carrying the memory of light that moved and of the Sun that learned to listen. At first, the interference looked like noise, random static scattered through the radio bands that have monitored the Sun for decades. But it wasn't random. Every 19 hours and 42 minutes, the static rearranged itself into structure. A precise distortion sweeping across the electromagnetic spectrum from gamma to microwave, as if the Sun had begun to speak in harmonics no human receiver was built to understand. The first reports came from the Deep Space Network near Madrid. Tracking antennas that usually listen to spacecraft noticed rhythmic dropouts, clean, narrow gaps that shifted frequency at constant velocity, a pattern too perfect for chance, too broad for a single transmitter. Within hours, dishes in California and Canberra saw the same thing. The Sun itself had become a source of interference. In ordinary conditions, solar radio bursts are chaotic. They roar when flares erupt, fade when plasma cools, and scatter into white noise shaped by turbulence. This was different. No flare, no rise in radiation, just a smooth, modulated signal sliding through the bands like a wave passing through glass. When technicians filtered the data, faint sidebands appeared mirror images of the carrier frequency, spaced in perfect integer multiples of the Atlas rhythm, the same 3, 2, 1 ratio. It was as though 2 oscillators, the Sun and something else, were beating together, producing interference fringes that spanned the entire heliosphere. To most engineers, interference means corruption. To physicists, it means overlap. 2 fields occupying the same space, adding and cancelling in precise proportions. If Three-Eye Atlas was transmitting magnetic or plasma waves into the solar environment, the overlapping fields could produce nodes of constructive and destructive interference, zones where energy vanished and zones where it doubled, and the doubling had consequences. During one constructive phase, satellites in near-Earth orbit experienced short bursts of electromagnetic drift. Clocks shifted by microseconds. Solar panels registered fractional surges in current. The fluctuations were small, but synchronized across spacecraft, separated by tens of thousands of kilometers. Space weather models couldn't explain them. The Sun was quiet, The interference wasn't. Spectral decomposition revealed something even stranger. The interference pattern carried information. Fine structure too, ordered to be natural plasma noise. In Fourier space, it resolved into repeating logarithmic spirals, the same geometry that governs magnetic flux loops on the sun's surface. The pattern looked alive, adaptive, like feedback seeking equilibrium. Researchers at Goddard began calling it the solar lattice. Each interference cycle seemed to remap the sun's magnetic topology, turning chaotic loops into organized grids for a few brief minutes before entropy reclaimed them. Under those conditions, localized bright spots appeared across the corona, glowing simultaneously at widely separated longitudes, as if the star's surface had been stitched together by invisible threads of coherence. Then, during one observation window, the lattice held longer than expected. For nearly 2 hours, the sun's magnetic field locked into perfect symmetry. Solar wind output dropped by 4%. Radio emissions flattened into a single tone audible, even in low-frequency receivers on Earth. A droning hum that swept across the spectrum before fading into silence. For that brief period, the sun's noise cancelled itself out. Total constructive and destructive interference perfection, and then collapse. When the symmetry broke, the star released a pulse of particles moving at relativistic speed, a narrow jet invisible in light, but detected in magnetic sensors throughout the inner solar system. It wasn't a flare. It was a correction, a release of energy displaced by whatever resonance had just taken hold. The official bulletins described it as an anomalous phase-locking event, but the people who worked closest to the data used another term quietly, one that never reached the press. Interaction window. They meant a moment when two systems, one humanly known, one utterly foreign, occupy the same frequency long enough for energy to move freely between them. And if that interpretation is true, then for 2 hours, the sun wasn't just reacting to 3 Atlas, it was synchronizing with it. What began as static had become a dialogue, and the interference far from corruption was the sound of 2 cosmic transmitters finding perfect phase. By the time the interference faded, the solar system had changed. Every probe, every telescope, every magnetometer from Mercury to the Kuiper belt showed the same anomaly. Background fields no longer returned to baseline. They oscillated gently, rhythmically, as if the very space between the planets were trembling. At first, the variation looked like low-frequency noise in the interplanetary magnetic field, but when the oscillations were plotted across multiple spacecraft, the pattern came into view, a wave that wrapped around the sun itself, standing perfectly still, in shape, yet alive in motion. Amplitude and phase aligned across billions of kilometers. Space had become an instrument resonating in its own key. The heliospheric observatory network called it the resonance field. No one knew what it was, only that it existed, a layer of invisible vibration suspended between matter and vacuum, anchored on one end by the sun, and, on the other, by 3 Atlas. Mathematically, it behaved like a coupled oscillator system. When one node moved, the other responded. Fluctuations in solar wind pressure caused ripples in the comet's tail. Perturbations in the object's field returned, mirrored pulses toward the Sunday. The delay between them was constant, 2 hours, 37 minutes, the travel time for electromagnetic information to cross the intervening space. Nothing else in astrophysics shows that kind of perfect bidirectional timing. The first visual evidence came from polarized light imaging around Mars' orbit. Dust particles aligned themselves along invisible threads, forming shimmering planes that rotated in harmony with the oscillations. They moved too slowly for wind and too precisely for turbulence. Every line traced a geometry reminiscent of a magnetic standing wave, a frozen ripple connecting 2 cosmic bodies. Some compared it to a plasma harp, each filament a string vibrating in sympathy. Others called it a bridge, a resonant domain where electromagnetic, gravitational, and perhaps even quantum fields overlapped. Whatever it was, the resonance field had turned the solar system into a coherent medium, a single structure singing to itself in a tone that instruments could measure but no human could hear. When the waveform was converted to sound for analysis, it produced a low, throbbing hum 27 Hz, barely above the threshold of human hearing. Listening to it felt less like hearing and more like remembering, a steady pulse, calm and ancient, as if it had always been there waiting to be noticed. The implications unsettled even the most conservative physicists. If the resonance field was real, it meant the boundary between magnetic and gravitational domains wasn't absolute. Energy could leak across it. Information could couple between them. The fabric of space-time itself might vibrate in response to the right stimulus. And that stimulus, somehow, was 3I Atlas. During one observation sequence, the resonance deepened. Sensors across multiple probes registered a coherent phase shift, a tightening of frequency, like a note reaching perfect pitch. At that exact moment, the sun's corona dimmed fractionally, and the object's coma brightened in equal proportion. Energy had moved not explosively, not destructively, but with precision, transfer, not loss. It lasted less than an hour. When equilibrium returned, the field's amplitude dropped, but never disappeared. The solar system continued to hum softly, each pulse fading just enough to remind those watching that the connection remained. The official explanation described it as a global magnetic coupling event, but within the closed circles of heliophysicists, a more poetic phrase emerged: the field that remembers, because even after the waves subsided, instruments still carried their imprint, a faint modulation buried inside every reading, as though space itself had acquired memory. No one can say how long it will last, or whether the field will dissolve once 3I Atlas drifts away. For now, it holds quiet, patient, balanced between a star and a traveller, and if you stand very still and filter out the noise of everything else, you might almost feel it too, the subtle vibration that runs through every atom of sunlight, a reminder that for a brief moment in cosmic history, the universe itself found resonance. For weeks, the resonance field held like a breath. Then, almost imperceptibly, everything began to move. The first to feel it were the planets. Tiny deviations appeared in their orbital telemetry, not enough to alarm navigators, yet impossible to ignore. Earth's day lengthened by a few milliseconds. Venus's upper atmosphere brightened in ultraviolet reflection. Jupiter's magnetosphere flared with new auroral bands, wide enough to encircle the planet twice. Each event was small, but together they drew the outline of a single cause. The solar system was reacting. From the outer rim, Voyager 2 detected a pressure increase in the heliosheath, a subtle thickening of plasma that arrived hours after a spike in the resonance field. Closer to the Sun, MAVEN recorded a rise in Martian ion density. The red planet sky briefly shimmered with sheets of green aurora visible even from its night side. And near Earth, magnetometers twitched every 19 hours, their rhythm locked once again to the Atlas clock. No explosion, no violence, only choreography. Every body, from dust grain to gas giant, shifted in time with an unseen metronome. At Goddard and ESA's solar division, researchers began to overlay the data: field strength, orbital drift, radiation flux, seismic resonance. When the graphs aligned, the pattern revealed itself. A wave of response spreading outward from the Sun at light speed, echoing back from each planet, as if the entire system had become a single resonant shell. They called it the Systemwide reaction. The term felt clinical, but behind it hid quiet astonishment. A star had vibrated, and every world it governed had answered. Energy, once confined to magnetic fields, was now coupling into gravity, atmosphere, even crust. Measurements of Earth's Schumann resonances, the electromagnetic pulses trapped between ground and sky, showed a faint harmonic at exactly the same frequency as the solar field. For the first time, the planet's own natural heartbeat matched that of the Sunday. Instruments aboard Parker Solar Probe confirmed the source. Each surge of the resonance field began with a tightening of the Sun's internal magnetic grid, a brief inversion that forced plasma inward rather than out. The energy did not disappear. It redistributed through the entire heliosphere, riding the lines of force like a tide that touched everything at once. To most observers, it was data. To those who lived with the numbers daily, it was something closer to communication. Not words, but recognition. As if the solar system itself had learned coherence. The effects reached even further. Radio transmissions between spacecraft grew clearer, their signal-to-noise ratios improving whenever the resonance peaked. Charged particles along the interplanetary medium moved more efficiently, reducing background radiation by measurable amounts. Space, momentarily, had become less hostile. In the labs, someone whispered that the system was tuning, like an orchestra warming before a symphony, each instrument finding its pitch, aligning to the same invisible frequency that 3I Atlas had introduced. Then, just as suddenly, the amplitude began to fall. The resonance field weakened, its waves stretching farther apart, as if the system had absorbed all it could. The sun's magnetic grid relaxed. Planetary fields settled back into ordinary noise, but something remained: a residual order, a clarity in the data never present before. The solar system had been changed not in structure, but in memory. Its fields carried a subtle bias toward harmony, a preference for the rhythm they had learned. Even after the resonance quieted, faint synchronous pulses continued to appear every 19 hours. They were smaller now, gentle reminders rather than commands, and somewhere beyond Mars's orbit, 3I Atlas kept moving, trailing a wake of calm magnetic geometry behind it. The visitor had not spoken, not sent a signal, not burned the sky, and yet every world had listened. When the final graphs were printed, a young researcher at ESA wrote a note in the margin. The system reacted as one organism. No one erased it, because in the silence that followed, with the sun cooling back into its ordinary rhythm, it no longer sounded like metaphor. It began without warning. For days the resonance field had weakened, fading into background silence. The solar system appeared to rest instruments steady, magnetic flux calm, radiation normal. Then, in the early hours of a quiet rotation, the sun responded. At 3:17 UTC, the Solar Dynamics Observatory detected a soft surge in ultraviolet emission across the equatorial belt. Not an explosion, not a flare, a coordinated brightening that spread evenly across the entire circumference of the star. For the first time in recorded history, the sun illuminated in unison, every active region rising together, every magnetic loop glowing as one continuous ring of light. To the naked eye, nothing changed. But in the data, symmetry replaced chaos. The solar surface pulsed once, then again, in perfect phase with the 19-hour rhythm. And this time, the wave did not originate from 3I Atlas. It began from within the star itself. For centuries, humanity has watched the sun as a source, never as a listener. Now it behaved like both generating and responding simultaneously, as though it had learned the pattern that once belonged only to the object moving through the dark. At NASA Goddard, analysts overlaid the new emission profile with previous field recordings. The result was exact inversion. The sun's pulse mirrored the waveform first detected near the comet. The two signals were equal and opposite, a perfect phase reversal. In physics, that means resonance has been achieved. The teacher and the echo have become one. Across the solar system, every instrument heard it. Voyager, still far beyond the heliopause, recorded a subtle shift in plasma frequency, a single synchronized hum sweeping through the interstellar medium. On Earth, magnetometers registered a whisper of motion, and in the skies above the poles, auroras flared brighter than prediction, their arcs tracing delicate spirals that matched the geometry of the magnetic corridor once stretched between the star and the traveler. The sun had answered back, not with destruction, but with reflection, returning energy it had once received, reshaping it, amplifying it, and sending it outward in all directions like a final broadcast. For 2 full days, the system glowed in equilibrium. Solar wind flattened to near-zero variance. Radio static disappeared. Signals between deep space probes arrived clearer than ever before, as if the vacuum itself had been scrubbed clean. It was as though the star had imposed silence on its own environment, a gesture of acknowledgement, or perhaps gratitude, to the object that had stirred it. Then, gradually, the effect began to fade. The resonance softened, the symmetry loosened, and the sun returned to its natural turbulence. Flares, noise, randomness. But beneath that noise, the rhythm persisted, buried deep in the corona, pulsing faintly every 19 hours, too quiet for the naked eye, too consistent to be coincidence. When 3I Atlas finally crossed the orbital plane of Earth and drifted outward toward the cold of interplanetary space, the sun released one last synchronized pulse, a single flash that rippled through every frequency, visible even from ground-based telescopes as a perfect ring of light expanding across the solar disk. It was brief, less than a second, but every observatory recorded it, and moments later, the object's coma brightened in reply. The exchange was over. 2 bodies, one a star, the other a wanderer, had met, resonated, and separated. Yet the memory of their interaction remained written into the physics of the space between them. The data teams called it the final response event, but in the quiet corridors of ESA and NASA, some began using another phrase, the acknowledgement, because what had begun as interference ended in symmetry. And for the first time, humanity witnessed a star respond, not through chaos or radiation, but through understanding. The sun had answered back, and in the rhythm it left behind, we learned that silence, too, can speak.